89851 Signal Generator Module. There are two versions of the module, and the first version is introduced first. The module can output sine and square waves of 0 to 70 MHz, respectively. After the frequency is 20 to 30 MHz, the waveform will become increasingly unclean. The module has parallel data interface and serial data interface. The maximum clock frequency of the module is 180 MHz. The module has 6 times the clock input, so a 30 MHz crystal oscillator is used. Module usage demo. The connection is shown in the figure. QOUT1 and QOUT to output square waves. ZOUT1 and Z to output sine wave. W_CLK for clock line, foo_AD for frequency update pin. Data is the data pin, rest is the reset pin. Using STM32F103 or CT6 as the main control board. Connect modules via serial interface. Sine wave output pin connected to oscilloscope. Turn on the power after connecting. Reset the motherboard. Adjust oscilloscope. Look at the oscilloscope again. The observable amplitude is approximately 2 volts. A sine wave with a frequency of 24 kHz. Re-oscilloscope probe connected to square wave output pin. Adjust oscilloscope. The observable amplitude is 5 volts. Square wave with a frequency of 24 kHz. The potentiometer on the module can adjust the duty cycle of the square wave. Rotate the potentiometer and observe the waveform again. The increase and decrease of the duty cycle can be seen. Next, another version of the 89851 is introduced. The module is capable of outputting sine and square waves of 0 to 70 MHz. After the frequency is 20 to 30 MHz, the waveform will become more and more chaotic. The maximum clock frequency of the 89851 is 180 MHz. 89851 with 6x clock input. Therefore, the 89851 uses a 30 MHz crystal oscillator. The functions of each jumper port and pin on the module are shown in the figure. JP1, select communication interface. JP2, select whether to generate a square wave. JP3, select IR pin to connect with external potential to adjust amplitude. Module usage demo. The connection is shown in the figure. Using STM32F103 or CT6 as the main control board. Connect modules via serial interface. Sine wave output pin connected to oscilloscope. Turn on the power after connecting. Reset the motherboard. Adjust oscilloscope. Look at the oscilloscope again. The observable amplitude is 1.2 V. A sine wave with a frequency of 1 kHz. JP3 short circuit generates square wave. Therefore, connect the oscilloscope probe to the square wave output pin. Adjust oscilloscope. The observable amplitude is 4 volts. Square wave with a frequency of 1 kHz. The potentiometer on the module can adjust the duty cycle of the square wave. Rotate the potentiometer and observe the waveform again. It can be seen that the duty cycle increases and decreases with the knob. Module demo ends.